Perhaps the question I'm asked the most is what drives the cost of logic apps? So I'm just going to give you a really quick overview of what's driving that. Because ultimately, when we host logic apps, and here I'm talking about logic app standard, they sit on a hosting plan, and a hosting plan ultimately is just compute, and you're paying for the compute. Now, the different types of plan, you've got the WS1, WS2, WS3, but ultimately all they're doing is setting different levels of CPU. So the higher that plan, the more CPUs you have. And the costs pretty much scale linearly with that. So again, it comes down to how much CPU, how much compute, that's what the cost is. Now, what's the magic number for how much compute you have to buy? And the answer, it appears, is 80. So we'll provide a link for this, but ultimately it seems like if you are running logic apps and you're running stateful logic apps, you can do approximately 80 actions per second. Follow the link, check it out. Now that means that you've got something then that you can optimize against, because if you know how many logic app executions you need a second, how many actions are in each logic app, you can then work out how much compute you need and hence how much that's going to cost you. And then if that's the problem, you can then start to look at some strategies for making that better. So the first thing is, do you need all your actions? So what we see a lot of the time is, for example, variable assignment. Do you need variables or do you need parameters? Because variable assignment is another action and you've just used another one for very little gain. So do you need all your actions? Another one, batching or set-based operations. It's an action to do stuff on a single unit. It's an action to do something as a batch or as a set. So can you do things in set-based operations? So instead of, well, I've got it last, but avoid looping. Because if you've got 100 things to loop through, and each one of those has got a whole ton of bits of work, really painful, really expensive. If you can do that all as set-based operations, the savings are massive. And finally, stateless versus stateless. Because stateful logic apps, one of the reasons why they take this amount of compute is because they're designed to be operationally bulletproof, which means that every time you do an action, the result of that is written back to storage, which is great from a recoverability and an operational point of view, but from a compute and a resource point of view, it's quite expensive. So if you find that some steps can be done in sequence, but they don't all have to be saved back to disk, you can actually make those stateless. And then that can save you an awful lot as well, because one stateless logic app effectively is one action, whereas if you've got a stateful logic app, you've got a whole load of, you've got to write back all the time. So there's just some quick thoughts. The number 80, follow the link, talk to me.